this is Unit 2.6, question 23. Given that g of x equals 2x to the fifth power plus b over x squared, where b is a constant, find the value of b if g prime of 2 equals 180. So the first thing I'm going to do is I'm just going to write g of x with the x squared on the top because that'll make it easier to take the derivative using the power rule. So I'm going to write g of x equals 2x to the fifth plus b times x to the negative 2 power. And this is the same thing as the original function g of x. So now it makes it easier to derive using the power rule. So I have g prime of x equals, I'm going to bring the 5 to the front, so I have 10x to the fourth power plus, or minus 2, because I'm going to bring the minus 2 to the front, b times x to the negative 3 power. And now I'm just going to rewrite this x to the negative 3 because that helps a little bit when I'm going to plug in a value next. So g prime of x equals 10x to the fourth minus 2b over x cubed. And this is our new g prime of x. So now we know that when we plug in 2 to the function, we should get 180. So let's plug in 2 to the function and set it equal to 180 and then just solve. So 10 times 2 to the fourth power minus 2b over 2 to the third power equals 180. 2 to the fourth power is 16. 16 times 10 is 160. Minus 2b over 8. 2 to the third power is 8 equals 180. And I can simplify this one more time, so I'm going to get 160 minus b over 4 equals 180. I'm going to subtract the 160. I'm going to go up here. I'm going to subtract the 160 from both sides. So I get negative b over 4 equals 20. And I'm going to multiply both sides by 4. So I have negative b equals 80. Lastly, I'm going to divide both sides by negative 1. So I get b equals negative 80 as our final answer. And that is, and in the actual question, that is any of the answer choices. So our final answer is E. Alright, this is Unit 2.6, question 24, and this time our calculator is allowed, so we will be using a calculator. Which of the following is an equation of the line tangent to the graph f of x equals x to the sixth power minus x to the fourth at the point where f prime of x equals negative 1? Well, first let's realize that this statement, f prime of x equals negative 1, means our slope of our equation is already given to us. It's negative 1. We're trying to find the point where, so to do the rest of our equation, let's remind the equation really quickly. Y minus y1 equals m x minus x1. We already have our slope m, which is negative 1. So all we're trying to solve for now is our 2 points. So now that we know our slope is negative 1, we can just find the point where f prime of x equals negative 1 by taking the derivative of the function, or finding f prime of x and setting it equal to negative 1. So let's start by finding f prime of x. So we can bring the 6 to the front and subtract 1 to the power from the power, and then same with this other function for x to the third power. So now we have our f prime of x. We're going to set that function f prime of x equal to negative 1 and solve for x, and that will be the x value of our equation, or the x1 value. Now to solve this, you actually can't solve it algebraically, so we're going to go ahead and use a calculator. What we're going to do is we're going to go to y equals, I don't know how well you can see it, probably not well at all, but we're going to type in this part of the equation, 6x to the fifth power minus 4x to the third power. And then our y2, we're going to type in this part, so just in the negative 1. We're going to hit the button trace, and it's going to show us both lines. We're going to go to second, and then calc, and then number 5, intersect. We're going to go to about where it intersects, and we're going to press enter, and press enter again, press enter a third time, and we get the intersection point of our x value at negative 0.9335. So I'm just going to round that off. X equals negative 0.9335 to 4 decimals, just to be safe. So now that we have our x value, we can find our y value by just plugging this function into our original f of x function. So to do this, we're going to use the calculator again. We're going to go parentheses, and then our x value that we have, negative 0.9335 to the 6th power minus negative 0.9335 to the 4th power. And we get an answer, y equals negative 0.0976 as our y value. Now I'm just going to write everything into the equation. And unfortunately, all our answer choices are in slope-intercept form, which means we're going to have to do some extra work after we do this. But first, let's do this. Y plus 0.0976 is equal to our slope, which is negative 1, times x plus, and then our x value, 0.9335. So now, we're going to have to put this into slope-intercept form by first distributing this negative 1 to both of these terms. So y plus 0.0976 equals negative x minus 0.9335. Finally, we're going to move this to the other side of the equation by subtracting it from both sides. I'm going to use the calculator for this. Negative 0.9335 minus 0.0976. And we're left with an answer of y equals negative x minus 1.0311. And this is our final answer. It rounds to answer choice A in the assignment. So that's how we get answer choice A. Alright, this is unit 2.6, question 25 on the test prep. We have the limit as h approaches 0 of 3 times x plus h squared plus 2 over x plus h minus 3x squared minus 2 over x all over h. So now, obviously, you can do this limit algebraically, but there's a much easier way to do this, and that's by recognizing that this is the definition of derivatives. So the definition of derivatives is that f prime of x equals f of x plus h minus f of x over h. Now, all we need is f of x, and then we can derive it from there using some other method other than this. So we can see that we're subtracting f of x, so we only have to worry about this part. And the fact that we're subtracting means we can just factor out a negative sign. So when we factor out a negative sign, we get 3x squared plus 2 over x, which means that's what f of x equals. F of x equals 3x squared plus 2 over x. So now I'm going to rewrite this to put them all to bring the x up to the top, just to make it easier when we finally derive it. 3x squared plus 2x to the negative 1 power. Now I'm going to finally derive it by using the power rule. So f prime of x equals, we're going to move the 2 to the front, we get 6x, and then we're going to move the negative 1 to the front, minus 2x to the power of negative 2 now. And we just have to, in our answer choice, we just have to rewrite this back into without the negative exponent. So we get 6x minus 2 over x squared as our final answer. Alright, this is unit 2.6, question 26. We know that f of x equals x squared over 4 and g of x equals negative 1/2 x plus 2. We know that there is a point P on the graph of f for x is greater than or equal to 0, at which the line tangent to the graph of x is f is perpendicular to the graph of g. Find the coordinates of point P. So, let's break this question down. We know we're trying to find a tangent line of f, and we know that it's perpendicular to the graph of g. Perpendicular means that the slope of this tangent line will have the negative reciprocal of the slope of our g of x function. So if our g of x function has a slope of negative 1/2, that means our slope of our new function is going to be 2. So now, what can we do with that information? Well, to find the slope of the tangent line, we have to derive this function. So let's just start by deriving x squared over 4. So d over dx of x squared over 4. And to make this a little bit easier, I'm going to go ahead and take the 1/4 out of the derivatives, because remember, when we have a constant times the derivative, we can take the constant out. The derivative of 2x squared is just 2x, so that leaves us with an answer of 1/2 x. So this is going to be our derivative of f of x, So now we need to find where the derivative is equal to our slope of 2. So we can do that easily by just setting 1 over 1/2 x equal to 2. And solving for x, we get x equals 4. So now we know our x value of our function. To find our y value, literally all we do is just plug in 4 back into our f of x. So you get 4 squared over 4, and that is 16 over 4, which is equal to 4. So our coordinates are 4, 4 as our final answer. Alright, this is Unit 2.6, question 27, Part A. We're given this, we're also given a lot more, but I can't write it, I can't fit it all on this whiteboard. So we're just going to do one part at a time. So first, our first question is find the average rate of change from t equals 3 to t equals 16. Our formula for the average rate of change is d of our max, which is 16, minus d of our minimum, which is 3, over 16 minus 3. So d of 16, when t is equal to 16, we're going to use g of t. G of 16 is 6,500. And then we're going to subtract. G of 3 is 64.5. All over 16 minus 3. And this is going to simplify to 12,871 over 26 as our final answer. Part B says to approximate d prime of 10, which basically we're finding the slope at t equals 10. So when t equals 10, we're going to use g of t. So t equals 10 is like right here. So if we find the slope about right here, then that will be d of 10. So we can just go 1 to the right, which is 12, and 1 to the left, which is 8, and use those numbers. So to find our slope, we do y2, which is 4, 0, 5, 0, minus y1, which is 2, 1, 0, 0, over 12 minus 8. And that will give us an answer of 975 over 2 as our final answer. Part C says, is d continuous from 0 to 16? So to find out if a function is continuous, we're going to look at its break, which is right at 3. We're going to take the limit, and we're going to take the limit from the left side and the right side and see if it's the same. So the limit as x approaches 3 of d of t from the left side will be equal to plugging in 3 into this function. So 20 times t plus, or not t, sorry, 20 times 3 plus 3 squared minus 3 cubed over 6. 20 times 3 is 60. 3 squared is 9. 3 cubed is 27. 27 minus 27 over 6. And this is about 64.5. Or it's not about 64.5. Now if we take the limit from the right side, limit as x approaches 3 from the right side of d of t, well, we can just see that if we plug in 3 into g of t, we get 64.5. So seeing how these limits are the same, they evaluate to the same from both sides, we can know that the function is continuous. And that's how we get our answer of continuous. Our final part, Part D, says to find d prime of 2. When t is 2, we're going to use this function up here. I'm just going to write it in x just to make it easier to read. So d of x equals 20x plus x squared minus x cubed over 6. Now we can take the derivative of each of these functions. The derivative of 20x is just 20, so d prime of x equals 20. The derivative of x squared is 2x, and the derivative of x cubed is 3x squared. 3 over 6 is just 1/2, so we're left with 1/2 x squared. And finally, we can just plug in our value of 2. So we have 20 plus 2 times 2 minus 1/2 times 2 squared. 20, we're going to leave 20. 2 times 2 is 4. 2 squared is 4, times 1/2 is 2. So we have minus 2, which gives us an answer of 22. And we have to use words or units. So 22 dirt per days as our final answer. Alright, that's all of 2.6. Next we'll be moving on to 2.7.